Welcome back to Statistics Made Simple, and I'm Savita Walsang. This is the first model paper which I have solved for the second PUC students who will be writing the board examinations this year. I really hope that this particular model paper which I have solved and the other two model papers, that is model paper 2 and 3, which I have solved, along with various other important and sure questions from certain topics, are going to be helpful to many of you. Section A, first main, choose the most appropriate answer from the choices given. 5 into 1 is equal to 5. First question, the life expectancy of a newborn baby. The options are radix, longevity, fertility, and fecundity. The correct option is longevity. Second question, the prices of items decreased by 10% in 2024 as compared to 2020. The index number for the year 2024 is, the options are 10, 90, 100 and 110. So we know that the base year index is 100. So the base year index, that means for 2020, is 100, and it has decreased by 10% in 2024. So 100 minus 10 will give us 90. So this will be the index number for the year 2024. So the correct option is 90. In a Poisson distribution, the third question, if lambda is equal to 2, the values of the modes are A 0, 3, then B 0, 4, C 3, 4 and D 1, 2. So in a Poisson distribution, lambda is equal to 2. That means it is an integer. So the values of the mode will be bimodal, that is lambda and lambda minus 1. So it will be 2 and 2 minus 1, which is equal to 1. So the correct options are 1 and 2, that is subdivision D. Fourth one, type 1 error is first option, rejecting H0 when H0 is true. B, rejecting H0 when it is not true. C, accepting H0 when it is true. And D, accepting H0 when it is not true. So the correct option is rejecting H0 when it is true. Fifth one, in inventory theory, shortage cost per unit good per unit time is denoted by, the options are P, C1, C2 and C3. So the shortage cost is denoted by C2. Second main, fill in the blanks by choosing the appropriate answers in the brackets. 5 into 1 is equal to 5. Sixth question, the dash price of the commodities are used in the construction of cost of living index number. The correct answer is retail. Seventh question, the value of variance and standard deviation of a standard normal distribution is, actually both of them are equal and the correct answer is 1. 8. A statistical constant of the population is called as a parameter. Then ninth, a small amount of variation for which no specific cause can be attributed is termed as dash variation. So this question is from the SQC chapter. The correct option is chance variation. 10th question, a transportation problem is said to be balanced if and only if summation AI is equal to summation BJ. That is, the sum of the availability should be equal to the sum of the requirements. Third main, match the following. 5 into 1 is equal to 5. The 11th question, 15 to 49 years, that is the childbearing age of females. Laspeyer's price index, it denotes an upward bias. Then chi-square distribution curve is leptokurtic. H1 P less than P naught is a left-tailed test. Then the least cost entry method, it is also known as the matrix minima method, and that is a solution for the transportation problem. So this is option E. Fourth main, answer the following questions. 5 into 1 is equal to 5. 12th question, mention one of the uses of vital statistics. There are about 8 uses. You can write any one of them. They are of great use in planning and evaluation of economic and social development of a country. They are useful to government agencies for administrative purposes. They are very much useful in medical research. They are essential in demographic research. They are highly useful to an individual by the way of recording birth, death, marriage, and divorce during his or her lifetime. They are also of great use at the international point of view. They are of great use to the government to assess the impact of family welfare programs in the country, and they are also used in actuarial science. 13th question, define time series. So data arranged in chronological order. So data arranged in chronological order in accordance to time is called time series. The next question, 14th one, write the mean of a Bernoulli distribution. So the notation is E of x. So E means it is expectation and x should be in capitals. It's a random variable. So E of x is actually the mean of the Bernoulli distribution, and the formula is it is equal to PQ, where Q is equal to 1 minus P. So note that P stands for the probability of success and Q stands for the probability of failure, and P and Q will always lie between 0 and 1. The 15th question, write the formula for standard error of P. So this comes under test for single proportion. So SE means standard error. So the formula is SE of small p. So P stands for the sample proportion. So this is root of PQ divided by N. Put a comma and write Q is equal to 1 minus P. 16th question, mention a need for replacement of equipment. So this question is from replacement theory. So first one, if the machine suddenly fails or is destroyed accidentally, it has to be replaced. Second, when the machine becomes outdated or obsolete because of technological development, newly designed machines will have to replace them. Third, when the machine wears out, its efficiency will reduce, and then the maintenance cost of such machines is very high. Hence, it is not worth to continue with such machines, and so we have to replace the machines. Fourth, a better or more efficient design of the machine or equipment has become available in the market. So you can write any one of them. Now moving on to section B, the fifth main, answer any 5 of the following questions. 5 into 2 is equal to 10. 17th question, mention a factor causing following variations in a time series. First one, seasonal variations, and second is cyclical variations. So the first one, as we know, seasonal variations, it can be because of the various seasons or it can be because of various weather conditions, or we say climatic conditions. Then second are the cyclical variations. So one of the factors that causes cyclical variations in the time series, it is because of economic or business activities. Now here under seasonal variation, there is another option also. It can be because of man-made conventions. 18th question. Write the two conditions for applying the binomial expansion method of interpolation and extrapolation. So first one, the x values should be equally spaced. Second, the values of y which have to be estimated should be corresponding to the values of x in the given data. So don't get confused with the conditions for interpolation and extrapolation. So these two are the conditions for applying the binomial expansion method. 19th question. In a Poisson distribution, if probability of x is equal to 0 is equal to 0.1225, write the probability mass function. So start the problem, write given. So they have given us probability of x equal to 0. That means P of 0 is equal to 0.1225. So usually they'll give us a value of lambda and then we find out the probability for a given value of x. But here they have already given us the probability and they have asked us to write the probability mass function. So if we have to write the probability mass function, we need to find out the value of the parameter lambda. So what you have to do is in the statistical tables, you have to search for the value 0.1225 under the Poisson distribution table. And when you search for 0.1225, you will see that the value of lambda is 2.1. So from the tables, we get lambda is equal to 2.1. Now let us write the PMF. So PMF is P of x is equal to, so PMF means probability mass function is denoted by P of x. So the formula is e to the power minus lambda. So e to the power minus 2.1 lambda to the power x. So 2.1 to the power x divided by x factorial, where x takes values 0, 1, 2, 3, so on. It is infinite, and then we write 0 otherwise. 20th question. Mention two features of the student's T distribution. So there are about 10 properties. We can write some of the simple ones. The first one is the mean, median and mode are all 0 for the student's T distribution. So E of T is equal to 0. Then the median, that is m, is equal to 0, and even the mode, that is z, is equal to 0. Second one, so this point actually means that it is a symmetric distribution, and we also know for a symmetric distribution beta 1 value is equal to 0. Then the second is the parameter of the T distribution. It is equal to n. Then third, if you want, you can write the range for the student's t distribution is minus infinity comma infinity. 21st question, define point estimation and interval estimation. So this is an important question. So if a single value is proposed as an estimate of the unknown parameter, then it is called as point estimation. And if we propose an interval in which the unknown population parameter lies, then it is called as interval estimation. 22nd question. In a paired t-test, if n is equal to 5, d bar is equal to 3 and sd is equal to 2, then what would be the value of the test statistic? So the test statistic which is used for the paired t-test is given by t. So you can write consider t is equal to, it is d bar divided by sd by root of n minus 1. So substitute the values which are given. So it is 3 divided by 2 by root of 5 minus 1. So this is 3 divided by 2 divided by root of 4, which is equal to 3 by 2, and root of 4 is 2. So now the first calculation you should do is 2 divided by 2. So it is 3 divided by 2 and 2 will get cancelled. You will get 1. So the final answer of the test statistic T is 3. 23rd question. In statistical quality control, if x bar dash is equal to 65, sigma dash is equal to 5 and n is equal to 5, then write the upper control limit of the x bar chart. So because x bar dash and sigma dash are given, this is a case when the process standard is known. So the formula for the upper control limit is UCL is equal to x bar dash plus a times sigma dash. So from the statistical tables, we get the value of a for n equal to 5 as, so you write the sentence from the tables, for n is equal to 5, a is equal to 1.342. So therefore UCL is equal to 65 plus 1.342 into 5. So the final answer you will get UCL is equal to 71.71. 24th question. For an equipment, the 4th year depreciation cost is rupees 6,000 and the cumulative maintenance cost is rupees 6,200. Find the average annual cost. So this question is from replacement theory. So first we will write down what is given in the question. So they have mentioned here 4th year. So that means n is equal to 4. Depreciation cost means it is P minus Sn, which is 6,000. And the cumulative maintenance cost, that means summation Ci, is equal to 6,200. So let us first write the formula for the average annual cost. So write, consider An is equal to P minus Sn plus summation Ci divided by n. So therefore, the average annual cost for the 4th year. So it will be A, in place of n, you write 4. This is equal to 6,000 plus 6,200 divided by 4, which is 12,200 divided by 4. So the final answer is rupees 3,050. Section C, 6th main, answer any 4 of the following questions. 4 into 5 is equal to 20. 25th question, calculate simple geometric mean price index number for the following data. So 4 items are given along with the prices in the base year and the current year. So the base year price you mark it as P0, the current year price you mark it as P1. Next, write given n is equal to 4 and write the formula for the simple geometric mean index number. So consider P01 of Gm is equal to antilog summation log P by n, where capital P is the price relative, which is P1 by P0 into 100. So each of these formulae will carry 1 mark. Next, in the table, form the column capital P is equal to P1 by P0 into 100 and take 2 places after the decimal after rounding off. So 21 divided by 14 into 100 is 150. 9 divided by 12 into 100 is 75. Then we get 135 and 89.29. Next, we need to find out log P. For log P, we should take 4 places after the decimal after rounding off. So log of 150 is 2.1761. Then log of 75, 1.8751. Log of 135, 2.1303. And then log of 89.29 is 1.9508. Then find out summation log P, which is 8.1323. So now substitute the totals in the formula. So you will get anti-log of 8.1323 divided by 4, which is equal to anti-log of 2.0331. And for the final answer, you can just take 2 places after the decimal after rounding off. So it is 107.92. 26th question, interpolate the value of y when x is equal to 70 by using Newton's advancing difference method from the following data. So the x values are given and the y values are given. So now whenever the x values are given, count the number of x values. In this case it is 5. So the leading differences will go on till delta to the power 4 column. So now the first step is to mark the first value in the x column as x0 and the first value in the y column as y0. Now form the column heading as leading differences. The first column here is delta to the power 1. Then you'll have delta square, delta cubed and delta to the power 4. So how do you find out delta to the power 1? It is 32 minus 20 is 12. So 12 is written in between 32 and 20 in this column. Similarly, it is 54 minus 32. So you will get 22. You write it in between 32 and 54 in this column. Then it is 90 minus 54. So you will get 36. Then 144 minus 90 is 54. Now similarly, delta square will be 22 minus 12 is 10. You write it in between 12 and 22 in this column. Then 36 minus 22 will be 14. Then 54 minus 36 will be 18. Next, find out delta cube. So 14 minus 10 is 4. 18 minus 14 is also 4. Next, 4 minus 4 is 0. So we will next mark the first value in delta to the power 1 column as delta naught to the power 1. 10 will be delta naught square. 4 will be delta naught cubed and delta to the power 4 column, the value 0 is delta naught to the power 4. So next you write Newton's interpolation formula. Consider yx is equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 by 3 factorial delta naught cubed plus x into x minus 1 into x minus 2 into x minus 3 by 4 factorial delta naught to the power 4. So now because delta naught to the power 4 is equal to 0, so this whole term will reduce to 0. So next you can write where x is equal to, so what is x formula? It is the given value in the question. So this is the given value minus x naught value, that is 20, and the denominator will be the difference between the second x value and the first x value. So it is 40 minus 20. So this is difference between second x value and first x value. So the most important step is to find the value of x. So let us simplify. So this reduces to, it is 70 minus 20 will be 50. So it is 50 divided by 20, which is equal to 2.5. So now let us substitute in Newton's forward interpolation formula. So therefore y, in place of this x, you have to put 70, which is equal to, substitute y naught is 20 plus 2.5 into 12 plus 2.5 into 2.5 minus 1. 2 factorial will be 2 into 10 plus 2.5 into 2.5 minus 1 into 2.5 minus 2 divided by 3 factorial will be 6, and the numerator will be multiplied by 4 plus the last term will be 0, that is this part will be 0. So this is equal to 20 plus 30 plus 2.5 into 1.5 into 10 divided by 2 plus 2.5 into 1.5 into 0.5 divided by 6 into 4. So add these two. So you will get 50 plus, when you multiply 2.5 into 1.5 into 10 divided by 2, you will get 18.75 plus 2.5 into 1.5 into 0.5 into 4 divided by 6 will be 1.25. So final answer is therefore y70 is equal to 70. Twenty-seventh question. 4 fair coins are tossed 96 times. Find the expected frequencies of number of heads obtained. So usually the 27th question is based on discrete distributions. So when a problem is related to coins, that is more than one coin, it falls in the category of the binomial distribution. So first let us write down the information which is given. So write given 4 fair coins means small n is equal to 4 are tossed 96 times. So capital N is equal to 96. Now they have said fair coins, and then they have also said find the expected frequencies of number of heads obtained. So in other words, the probability of getting a head when the coin is fair is 0.5. So small p, which is the probability of success, which is probability of getting a head, is p equal to 0.5. This is because of the word fair. Then we need to find out q, which is 1 minus p. So 1 minus 0.5 is equal to 0.5. Now let us continue with the problem. The next step is to define x. So capital X denotes, you write number of heads. Next we have to write the PMF. So PMF is P of X equal to, open the flower bracket, NCX, that means 4CX, P to the power X, so 0.5 to the power X, Q to the power N minus X, so 0.5 to the power 4 minus X. X takes values from 0 to N, so X takes values 0, 1, 2, 3, 4, and then we write 0 otherwise. Now the next step is to put different values of x from 0 to 4 and then find out the corresponding probabilities. So when x is equal to 0, we get p of 0 is equal to 4c0, 0.5 to the power 0, 0.5 to the power 4 minus 0, which is equal to 4c0 is 1. Any number to the power 0 is also 1. And then you will get 0.5 to the power 4. So 0.5 to the power 4 will be 0.0625. So 0.0625 into 1 will be 0.0625. Similarly, put x as 1. So P of 1 is equal to 4C1, 0.5 to the power 1, 0.5 to the power 4 minus 1. So 4C1 is 4, 0.5 to the power 1 is 0.5, and then you will get 0.5 to the power 3. So this will be equal to 4 into 0.5 into 0.125, which is equal to 0.25. Next, put x as 2. So P of 2 is equal to 4C2, 0.5 to the power 2, 0.5 to the power 4 minus 2. This is equal to 4C2 will be 6 into 0.25, and here also you'll get 0.5 to the power 2, which is 0.25. So when you multiply 6 into 0.25 into 0.25, you will get 0.375. Similarly, put x equal to 3. So P of 3 is equal to 4C3, 0.5 to the power 3, 0.5 to the power 4 minus 3. So 4C3 will be 4 into 0.125, and you will get 0.5 to the power 1, which is 0.5. So on simplification, you'll get 0.25. And then last, when x is equal to 4, P of 4 is equal to 4C4, 0.5 to the power 4, 0.5 to the power 4 minus 4. So 4C4 is 1, 0.5 to the power 4 is 0.0625, and here you'll get 0.5 to the power 0, which is 1, so 0.0625. So next we will form a table, and in the table we'll write down the corresponding x values, the corresponding probabilities, and then we have to find out the expected frequencies. So form a table with 3 columns. First write x, 0, 1, 2, 3, 4. Next column you write P of x. So 0.0625, 0.25, 0.375, 0.25 and 0.0625. Next, we find out the expected frequencies, that is Tx is equal to capital N into P of x. So this column is the expected frequency, or it is also called as the theoretical frequency. So 0.0625 you should multiply with 96. So you will get 6. Then 0.25 into 96 will be 24. 0.375 into 96 will give us 36. Then next is 24 and 6. So when you add up this column, you will get 96, which is same as our capital N. Twentieth question. Find the mean and variance of a hypergeometric distribution with parameters a equal to 4, b equal to 8 and n equal to 6. So let us start with the first subdivision. You can write the formula for the mean of the hypergeometric distribution. So consider expectation of x is equal to NA divided by a plus b. So this is equal to 6 into 4 divided by 4 plus 8, which is 24 divided by 12. So we get expectation of x is equal to 2. Next, write the formula for variance of x. So consider V of x is equal to, now an easy way to remember the formula is if you know expectation of x formula, so you write NA, multiply it by B. So the numerator you can remember it as the word NAB, and then the denominator you have to square it, so it is A plus B whole square. Now there are additional two terms in the numerator and denominator. So here you have a plus b minus n, and the same will come in the denominator as a plus b minus 1. So this is an important formula to remember, especially the variance. Sometimes this can come as a 2-mark question as well. So this is equal to 6 into 4 into 8 into 4 plus 8 minus 6 divided by 4 plus 8 the whole square into 4 plus 8 minus 1. So this is, when you multiply 6 into 4 is 24. 24 into 8 will be 192 into 6 divided by, here you will get 12 square. 4 plus 8 is 12. 12 square is 144 into 4. So this is equal to 1152 divided by 1584. So you will get variance of x is equal to 0.7273. 29th question. A sample of 64 students taken from a school. The mean and standard deviation of their heights are 151 centimeters and 4 centimeters respectively. Test at 1% level of significance that average height of students is 150 centimeters. Now first look out for the words which are there in the question. So here we have taken only one sample and the word mean is there and standard deviation is there. So it is test for single mean. Next is you should see whether n is greater than 30 or it is less than or equal to 30. So because n is greater than 30, it is large sample test, that is test for single mean. So you need 4 values from the problem. So start the problem now. Let us write what is given. So given n is equal to 64. The mean and standard deviation of their heights means that is the mean and standard deviation of the sample. So x bar is equal to 151. Standard deviation of the sample means it is denoted by s, which is equal to 4. And then the other value which we need is mu naught, that is the population mean. So whenever they ask a question, test at 1% level of significance. So whenever a question is asked, the value which occurs in the question, this will be the parameter value. So the word average is there. So the population mean, that is denoted by mu naught, which is equal to 150. And then we write alpha is equal to 1%. Next is you write H naught. So you can write the population mean is 150, that is mu is equal to 150, or we can just write in terms of notation mu is equal to 150. And because words like more, less, above, below, increase, decrease are not there, it will be a two-tailed alternative, that is mu is not equal to 50. Next, write the formula under H naught. The test statistic is, so z is equal to, it is x bar minus mu naught divided by, now it will be s by root n, which follows normal 0, 1. So this is equal to 151 minus 150 divided by 4 by root 64. So this is equal to 1 divided by 4, and root of 64 is 8. So this is equal to 1 divided by 4 divided by 8 will be half, or it will be 0.5. So 1 divided by 0.5, this is equal to 2. So now before we move on to the next step, we have to write the condition at the side. So as this is a two-tailed test, the condition will be, so write the condition. So the condition for a two-tailed test for large samples is you have to check whether mod z is greater than or equal to k alpha by 2. If this condition is satisfied, we reject H naught, otherwise we will accept H naught. So this is the condition. So we have got only z equal to 2. But what does the condition require? It requires mod z. So therefore, mod z is equal to modulus of 2, and modulus of 2 will remain as 2. So only the modulus of a negative number becomes positive. Next, we need k alpha by 2. So you write at 1% level of significance, k alpha by 2 is equal to 2.58. Now the last step is to write the conclusion. So conclusion is, since mod z is equal to 2, you have to compare it with k alpha by 2. So k alpha by 2 is equal to 2.58. So check whether 2 is greater than 2.58. It is not greater. So you'll write at 1% level of significance, we accept H naught. And when you accept H naught, you should write what is there under H naught. So, and conclude that mu is equal to 50. 30th question, solve the following game by using maximin minimax principle. Is the game fair? So you have player A with 4 strategies A1, A2, A3, A4, and player B has 3 strategies B1, B2 and B3. So now maximin minimax principle, the first step is to find out the row minimum. So here you can write row minimum and then we need column maximum. So here I'll write column maximum. So the row minimum has to be circled and the column maximum we put a box around it. So the minimum value in this row is -1. So you can circle it and here write -1. Similarly in the second row also the minimum value is -1. So circle it and write here -1. In the third row also the minimum value is -1 and then we write -1. In the fourth row the minimum value is 0, so circle 0 and write 0 here. Next, column maximum. Okay, so in the first column, that is B1, the maximum value you should write, it is 4. Sorry, it is 2. So you put a box around 2. Both the 2's you put a box and then write 2. Now in the second column, the maximum value which is there is 0. So for both the zeros, you put a box and then here you write 0. And in the third column, the maximum value is 4. So put a box and then you write 4. So usually where we have the circle and the box, that is where the saddle point is and that would be the value of the game. But there are certain steps which we are supposed to write. Okay, so you start with now maxi-min. Okay, so consider the word maxi-min. So maxi-min, you can split it as maximum of the minimum values. So this is equal to maximum of the minimum values are -1, -1, -1 and 0. So the maximum among this is 0. Similarly, and you consider mini-max. So mini-max, you split the word as minimum of the maximum, which is equal to minimum of the maximum values are 2, 0 and 4. Now you see what is the minimum of these, that means the least here. So this is equal to 0. So therefore you get maxi-min is equal to mini-max is equal to 0. So therefore the value of the game is 0. Then you can also write the best strategies for the players A and B respectively are. Now see the table, wherever you have the circle and the box, that would be the saddle point. And then you see what are the corresponding strategies. It is A4 and B2 are A4, B2. Now they have asked us another question, is the game fair? So whenever the value of the game is 0, it is a fair game. You write, therefore, the game is fair. 31st question. There is a demand for 10,000 items per year. The replenishment cost is rupees 200 and the maintenance cost is rupees 10 per year. Replenishment is instantaneous and shortages are not allowed. Find first the economic order quantity and second the reorder time. So this is under inventory theory and it is the case of without shortages. They have already mentioned that shortages are not allowed. So let us first write the terms which are given. So demand is denoted by R, which is equal to 10,000 items per year. Now it is also important to observe whether everything is expressed in years, otherwise we have to make changes. But here in this question, everything is expressed in terms of years, so we retain it as it is. Now replenishment cost is 200 means it is denoted by C3, which is equal to 200. Maintenance cost is denoted by C1, which is equal to 10. So this is a very simple problem. So you can write subdivision A, side heading you can write economic order quantity. So the formula is consider Q to the power 0 is equal to root 2R C3 divided by C1. So this is equal to root 2 into 10,000 into 200 divided by 10. So this is equal to, when we simplify, we get root of 4 lakhs, or finally you get Q to the power 0 is 632.46, or we can simplify further, that is you can round it off because it is in terms of units. So Q to the power 0 or the economic order quantity is 632 units per year. So next we find out the reorder time. So second subdivision, you write the side heading as reorder time. So the formula is consider T to the power 0 is equal to Q to the power 0 divided by R, which is equal to 632 divided by 10,000. So you get T to the power 0 is 0.0632 and the units we write it as years. The seventh main, answer any two of the following questions. 2 into 5 is equal to 10. 32nd question. This is a sure question on the normal distribution. The weight of persons is normally distributed with mean 70 kgs and standard deviation 4 kgs. Find the probability that a randomly selected person whose weight is first subdivision more than 62 kgs and second subdivision less than 74 kgs. So let us first write down the terms which are given. So write given. The mean is 70, so it means mu is equal to 70. Standard deviation means sigma, this is equal to 4. Next, you define capital X as weights of persons. Next, define Z. So write, we know that Z is equal to X minus mu divided by sigma follows normal 0, 1. So we know that Z is called as a standard normal variate. Now start with the first subdivision. Subdivision A, consider probability of X more than, that means greater than 62. Now if you have seen my important question video on normal distribution, you will know that the tables is in terms of Z but the problem is in terms of x, so you have to standardize. So standardize means from x subtract mu and divide by sigma, and even from 62 you should subtract mu and divide by sigma. So this is equal to probability of x minus mu by sigma is z. This is greater than 62 minus 70 divided by 4. So you get this as probability of z greater than, you will get minus 8 divided by 4, which is minus 2. Now the next step is you should draw the standard normal curve. So center line is z equal to 0. Then mark minus infinity and infinity. Next, see the number here. It is minus 2. It is negative. So mark it on the left tail, that is z is equal to minus 2. Next, you should see the sign. Whenever you have greater than symbol, you have to shade to the right side of the value. So from minus 2 to infinity, you have to shade. So shade from minus 2 to infinity and write it in words. So this is equal to area from minus 2 to infinity. So remember that from the statistical tables for the standard normal distribution, you can find out the area from any number to infinity. So your final answer will be probability of x greater than 62 is equal to, under z column search for minus 2, and then under column 0 you will get the area as 0.9772. Remember that probability answer should always lie between 0 and 1. Now let us move to the next subdivision. You should find the probability that a randomly selected person's weight is less than 74 kgs. So write, consider probability of x is less than 74. Now again you have to do the same steps, you have to standardize. So this is equal to probability of x minus mu by sigma is less than 74 minus 70 divided by 4. So this is equal to probability of x minus mu by sigma is z is less than, you will get 4 by 4, which is equal to 1. Next, draw the standard normal curve. So this is z equal to 0, then minus infinity and infinity. Then now look at the value here. It is 1, it is positive. So mark it on the right tail, z is equal to 1. Then look at the sign, it is less than. So it means you have to shade to the left side of 1. So from 1 till minus infinity you have to shade. Now write it in words. So this is equal to area from 1 to minus infinity. Now the most important step, minus infinity. Okay, we cannot find out the area from any number to minus infinity in the standard normal table. So now you have to rewrite this step. So this is equal to area from. So now what happens is whenever you have minus infinity, you should change the sign throughout. So 1 will become minus 1, and then minus infinity will become infinity. Now how can we write this step? We can write this step because the normal distribution is a symmetric distribution. So only because the normal distribution is a symmetric distribution, the area from 1 to minus infinity will be the same as the area from minus 1 to infinity. So this is equal to, under z column search for minus 1 and then look under column 0. So you will get probability of x less than 74 is equal to 0.8413. 33rd question. In 60 throws of a single die, the following distribution of faces are obtained. So in the table, they have given phase from 1 to 6 and the corresponding frequencies are given. Test at 5% level of significance that the die is unbiased. So when they ask a question like this, test whether the die is unbiased. Only with regular practice you will know that this problem comes under chi-square test for goodness of fit. So let us first write down the information which is given. So they have said that in 60 throws of a single die. So you can write given capital N is equal to 60 and then write alpha is equal to 5%. So next I've rewritten the table again. Let's come back to the table after a little while. Now the next step is we have to write H naught. So in goodness of fit test, whatever is asked in the question, that will be your H naught and its opposite will be H1. So H naught will be the die is unbiased versus H1, the die is biased. Next you write the test statistic. So under H naught, the test statistic is so it is chi-square equal to summation O minus E whole square divided by E, which follows chi-square n minus 1. So when you're writing the summation, you should cover both the numerator and denominator, where we have to write the formula for E. So E stands for the expected frequency or the theoretical frequency and O stands for the observed frequency. So E is calculated using the formula N into P of X. Now let us go to the table and do the other calculations. So firstly, you have to mark phase as X, then frequency. So frequency will be both F and it will also be O. So here you can write capital N is equal to 60 and this is same as summation O. Next, we have to find out E. So E is N into P of X. So now in the given question, actually the number of faces on a die is 6. So in this given part, you can also include N is equal to 6. That is the total number of outcomes. Now let us calculate E here. So capital N is 60 and P of X. So X is what? It is the phase or the number occurring on the die. So probability of any number occurring on a die is 1 by 6. So using the formula m by n over here, so it is 60 into 1 by 6, that is 10. So now let us form a E column and throughout you have to write 10. So you'll get summation E also as 60. So always summation O is equal to summation E, which is equal to 60. Next, what we have to do is you have to form O minus E the whole square. So 15 minus 10 is 5, 5 square is 25. Then 8 minus 10 is minus 2 square is 4. So similarly, next one is 16. Then you'll get 4, 16 and 25. Now the last column you need to form is O minus E whole square divided by E, which is 25 divided by 10 is 2.5. Next is 0.4, 1.6, 0.4, 1.6 and 2.5. So summation O minus E whole square by E is equal to, when you add up these values, you will get 9. So next let us find out what is chi-square. So therefore chi-square is equal to, so summation O minus E whole square by E from the table is 9. So we get chi-square is equal to 9. Next at the right, side, you have to write the condition for a chi-square test for goodness of fit. So goodness of fit test is a right-tailed test. So the condition for a right-tailed test is chi-square is greater than or equal to k2. So if this condition is satisfied, then you will reject h0. So let us write the degrees of freedom. Degrees of freedom is n minus 1. So 6 minus 1 is equal to 5. Now another important point to remember here is all the expected frequencies should be greater than or equal to 5. So suppose if any of these expected frequencies were less than 5, then we have to make use of the method of pooling. So usually in these kind of problems, usually E will be greater than 5. But if you're fitting a binomial distribution or fitting a Poisson distribution and then doing goodness of it, then sometimes there is a possibility that any of the E values may be less than 5. So now here we have to find out what is K2. So at 5% level of significance for 5 degrees of freedom, we have to find out K2. So K2 value is 11.1. So K2 is equal to 11.1. Then you write the conclusion. So since chi-square is equal to 9, K2 is equal to 11.1. So 9, it is not greater than 11.1. So at 5% level of significance for 5 degrees of freedom, we accept H0 and conclude that the die is unbiased. Thirty-fourth question. Following are the number of defects observed in a process. Obtain the suitable control limits. The sample numbers are given from 1 to 8 and the number of defects are given. So whenever they use the word defects, it is the C chart. And if they use the word defective, then it is the D chart or the NP chart. So number of defects, you mark it as C. The number of samples, it is denoted by K. So let us write the steps given. K is equal to 8. Then you can write the side heading as C chart, case when the process standard is unknown. So that means actually lambda is unknown in this case. The next sentence you have to write is the 3 sigma control limits are. So CL is equal to C bar, UCL is equal to C bar plus 3 times root C bar, LCL is equal to C bar minus 3 times root C bar, then where C bar is equal to summation C divided by K. So now in the table, the C values are given, that is the number of defects are given. So you add up the defects. So when you add up the defects, you get summation C as 30. So it is 30 divided by 8, which is 3.75. So it is 3.75. Now let us substitute in the formula all the values. So you'll get, therefore CL is equal to 3.75, UCL is equal to 3.75 plus 3 times root of 3.75, which is equal to 3.75 plus 3 into 1.9365. So this is equal to 3.75 plus 5.8095, or we get UCL is equal to 9.5595. Similarly, LCL is equal to, so the only change will be if we substitute here, that is C bar minus 3 times root C bar, you will get this step with the negative sign. So it is 3.75 minus 5.8095. So this is equal to minus 2.0595. But LCL cannot be negative, that is, the number of defects cannot be negative. So whenever you get a negative value for LCL, you approximate it to 0. So therefore, the final limits are CL is 3.75, then UCL is 9.5595, and LCL is approximately equal to 0. 35th question, solve the following linear programming problem graphically. Minimize z equal to 10x plus 8y subject to constraints 4x plus y greater than or equal to 40, 2x plus 3y greater than or equal to 60, and x comma y is greater than or equal to 0. So 35th question is a fixed question. It's an important one which is always based on a linear programming problem. So now let's start with the first step. So the first step is to convert inequalities to equalities. So write step 1. Convert inequalities to equalities. So it will be 4x plus y is equal to 40 and 2x plus 3y is equal to 60. Now step 2 is we have to draw these two lines. So to draw a line, you need a minimum of 2 points. So step 2 is to obtain the points of the two lines. So you start with the first equation. So write, consider 4x plus y is equal to 40. So first you put x equal to 0. So you'll get y is equal to 40. Second, you put y equal to 0. So you'll get 4x is equal to 40, which implies x is equal to 40 divided by 4, which is equal to 10. So therefore 0, 40 and 10, 0 are the 2 points of the first line. Then similarly you take the second equation. So you consider 2x plus 3y is equal to 60. Now you put x equal to 0. So you'll get 3y is equal to 60, which implies y is equal to 60 divided by 3, which is equal to 20. And next you put y equal to 0. So you'll get 2x is equal to 60, which implies x is equal to 60 divided by 2, which is equal to 30. So therefore 0, 20 and 30, 0 are the 2 points. So now step 3 is to draw the graph. So I have already drawn the graph. to draw the graph. So that is drawn over here. So now let me explain how to draw the graph. So now we have to mark the points 0, 40, 10, 0 for the first line, and 0, 20 and 30, 0 for the second line. So on the x-axis you can take 0, 10, 20, 30, 40, and similarly on the y-axis you can take 0, 10, 20, 30 and 40. So mark the first point 0, 40, that is here, and then you mark 10, 0, which is here. Mark these 2 points, and on that line you write 4x plus y equal to 40. Next you mark 0, 20, that is here, and then you mark 30, 0, that is here. Join these 2 points, and on that line you write 2x plus 3y is equal to 60. Next, write the scale. X-axis 1 centimeter is 10 units and y-axis 1 centimeter is equal to 10 units. Now the next step is to obtain the feasible region. So step 4, to obtain the feasible region. So now to obtain the feasible region, we should consider the inequalities which were given. So consider 4x plus y is greater than or equal to 40. In this you put both x equal to 0 and y equal to 0. So on the left hand side you will get 0. On the right hand side you have 40. You have to check whether 0 is greater than 40. It is not greater. So we get the condition as false. So similarly, take the next inequality. Consider 2x plus 3y greater than or equal to 60. Again, put x equal to 0 and y equal to 0. So you'll get 0 on the left hand side and you have 60 on the right hand side. 0 is not greater than 60, so you write false. So now we have to do the shading part in the graph. So for both the equations, we got the condition as false. So whenever you get false, you have to shade away from the origin. That means on top of the line. So you take the first equation, that is 4x plus y equal to 40, and then you shade on top of this line. Okay, so I've used the zigzag lines. So away from the origin, that is, I've used black color zigzag lines, and then you take the other equation 2x plus 3y equal to 60. Even that the condition is false, so you have to shade away from the origin on top of the line. So I've used blue color. Now what you should do, you have to see where both the types of shading are there. So if you take this particular area, there is no shading at all. If you take this triangle, only the zigzag lines are there. If you take this triangle, you have only the blue lines, but only this open area, it has the zigzag line as well, it has the slanting blue lines. So for a minimization problem, you should always get, you need not get a closed figure. It can be an open figure or a closed figure. Here we have got an open figure. Even then you will have a solution. So now we have to find out where both the types of shading meet, and then you have to mark these as the corner points. So the corner points are A, B and C. So A is 0, 40 and C is 30, 0. Now you have to find out B correctly. So B, if you see here on the x-axis, this point will be 6, and on the y-axis this point over here is 16. So B is 6, 16. So next you write step 5. So step 5, you should write the corner points. So the corner points are A is 0, 40. Then you have B, that is 6, 16, and C 30, 0. So now the last step is to evaluate the objective function at the different corner points. So you can write step 6. as evaluate Z at the corner points. So take the objective function. So consider minimize Z equal to 10x plus 8y. So next you find out ZA. So ZA will be 10 into 0 plus 8 into 40. This will be equal to 320. Similarly, find out ZB. So ZB is 10 into 6 plus 8 into 16. This is 60 plus 128 is equal to 188. And then ZC, that is 10 into 30 plus 8 into 0 is equal to 300. Now because the objective function is a minimization problem, you have to find out the least z value. The least z value is 188. So next, write the last step, which is the conclusion. So conclusion is the given LPP has an optimal solution at, you should write the point B 6, 16, and the minimum value of Z is equal to 188. So note that a minimization LPP can have an open figure, or it can also have a closed figure to have a solution. Section D, 8th main, answer any two of the following questions. 2 into 10 is equal to 20. 36th question, calculate gross reproduction rate and net reproduction rate for the following data and comment on the result. So the age group in years are given from 15 to 19 up to 45 to 49, and the corresponding male population, the female births and the survival rates are given. So let us start the problem. We'll start with the first subdivision, subdivision A, that is GRR. So write the formula, consider GRR, that means gross reproduction rate, is equal to 5 times summation WSFR. WSFR is women specific fertility rate. So this formula will carry 1 mark. In the next line you can write where WSFR is equal to FBX divided by FPX into 1000. So FBX means female births in the age group X, and FPX means female population in the age group X. So let us go to the table and then mark the columns which are given, and let us do the calculations. So FPX is a female population. So first mark the columns correctly. Female births means FBX and the survival rate is S. So let us form the column WSFR, and I will also form the next column WSFR into S, which we will require for the net reproduction rate, that is NRR. So WSFR is 24 divided by 2000 into 1000, that will be 12. Similarly, 204 divided by 3000 into 1000 is 68. The next one is 80. Then you have 56, 30, 20 and 6. Next, find out the total of summation WSFR. So when you add up all these values, you will get 272. So let us also complete the calculations for WSFR into S, and then I'll do GRR and NRR. So now be careful, WSFR into S means it is 0.9 into 12, that is 10.8. Then 0.9 into 68 is 61 divided by 2. Next is 72. Then 44.8. Then 24, 14 and 4.2. So summation WSFR into S is equal to, it is 231. So now I go back and do the calculations for GRR, and then I will complete it for NRR. So therefore GRR is equal to, it is 5 into 272, which is equal to 1360 female births per 1000 women. Next we find out GRR per woman, that is GRR divided by 1000, which is 1360 by 1000, which is 1.36. So whenever GRR per woman is greater than 1, it indicates that the population is increasing. Next, write the formula for NRR, that is net reproduction rate. This is equal to 5 times summation WSFR into S. So there's no need to write the formula again for WSFR as we have already written. So you can only substitute the total. So from the table, summation WSFR into S is 231. So therefore NRR is equal to 1155 female births per 1000 women. So next find out NRR per woman. So therefore NRR per woman is NRR divided by 1000, which is equal to 1155 divided by 1000, which is 1.155 greater than 1. Therefore the population is increasing. Thirty-seven question. Show that Fisher's index number satisfies time reversal test and factor reversal test for the following data. So items are given as ABCD. Then 2019 is the base year. The prices and quantities are given. And 2024 is the current year. The prices and quantities are given. So now let us write the condition for the time reversal test. So subdivision A, to verify Fisher's index number satisfies TRT, that is P01 of F into P10 of F is equal to 1. This will carry 1 mark. Now remember that when we write the formula for P01 of F and P10 of F, we do not multiply by 100 because it should be considered as only a ratio and not expressed in terms of percentage for TRT and FRT. So let us first write the formula for P01 of F. How to remember the formula I have already taught you in my previous videos. So it is last payer's price index number without the 100. So root of summation P1 Q0 by summation P0 Q0. This is last payer's index number without the 100. multiplied by Paget's index number without the 100, that is summation P1 Q1 by summation P0 Q1. Similarly, write the formula for P1 0 of f, which is root of. So in this formula, if you replace 1 by 0 and 0 by 1, then you will get the formula for P1 0 of f. So now let us go back to the table and then form the columns which are required. So the columns which you will require are P0 Q0, then you have P1 Q1, then P1 Q0 and P0 Q1. So let us find out P0 Q0. So before that I have to mark the columns correctly. So this is P0, this is Q0, this is P1 and this is Q1. So 10 into 15 is 150, 14 into 20 is 280, then we get 510 and 500. So summation P0 Q0, this is equal to 1440. Next we'll find out P1 Q1. So it is 14 into 25, which will be 350. Next is 20 into 30 is 600, then 675 and 960. So summation P1 Q1, this is equal to, you will get 2585. Next find out P1 Q0. So it is 14 into 15, that is 210, then 20 into 20 is 400, then you have 450 and 750. So summation P1 Q0, this total is equal to 1810. The last column is P0 Q1. So P0 Q1 is 10 into 25 is 250. Then 14 into 30 is 420. Then we get 765 and 640. So summation P0 Q1 is equal to 2075. So now that we have completed all the calculations, let us substitute these totals in these two formulae. So this is equal to root of summation P1 Q0. So 1810 divided by 1440 into 2585 divided by 2075. Similarly, substituting the totals in P1 0 of f, you will get root of 2075 divided by 2585 into 1440 divided by 1810. So now multiply both. Therefore, P01 of f into P10 of f is equal to, so draw a long square root and write all these 8 totals. So all the totals will get cancelled, and so you will get root of 1, which is equal to 1. So therefore we have P01 of f into P10 of f is equal to 1. So write the conclusion. Therefore, Fisher's index number satisfies TRT. Now let's start with subdivision B. To verify Fisher's index number satisfies FRT, that is P01 of f into Q01 of f is equal to summation P1 Q1 divided by summation P0 Q0. So first write the formula for P01 of f, which is root of, it is the product of last payers and purchase price index numbers without the 100, and then Q01 of f is the Fisher's quantity index number, which is obtained as a root of. So in P01 of f, all you have to do is replace P by Q and Q by P, which will result in the root of last payers and purchase quantity index numbers without the 100. So again keep in mind that both the TRT and the FRT, when you write the condition, it should not contain 100. So now let us substitute the total. So this is root of 1810 divided by 1440 into 2585 divided by 2075. Similarly, substitute the totals for Q01 of f. So it is root of 2075 divided by 1440 into, it will be 2585 divided by 1810. Now find the product of P01 of f into Q01 of f, which is equal to root of, you have to write all these 8 totals. Now you will observe that all the terms will not get cancelled, but only 4 terms will get cancelled. So observe carefully and cancel out the totals which are the same. So 1810 will get cancelled and 2075 gets cancelled, which is equal to root. Then you have 2585 into 2585 in the numerator. Then in the denominator you have 1440 into 1440. So it is written as root of 2585 divided by 1440 the whole square. So you should write this step correctly, and then the square and the root will get cancelled, and what remains is 2585 divided by 1440. So if you observe carefully, 2585. So 2585 is nothing but summation P1 Q1 and 1440 is summation P0 Q0. So therefore you got P01 of f into Q01 of f is equal to summation P1 Q1 by summation P0 Q0. So therefore Fisher's index number satisfies FRT. Thirty-eighth question, subdivision A. Find the trend values by 5-yearly moving averages for the following time series. This question carries 5 marks. The years are given from 2016 up to 2024 and the corresponding values are given. So let us start the problem. So write given. I'll just change the color of the ink. So first let us write given. So m is equal to 5. So m is called as a period of variation, and because they have asked us to find out 5-yearly moving averages, m is equal to 5. It is an odd number. So whenever m is odd, we'll have only 2 columns, that is 5-yearly moving total, and then we will have 5-yearly moving averages, which is also called as the trend values. Now the method is quite simple. So first what we have to do is we have to find out the 5-yearly moving totals. So add 40, 44, 41, 47, 43 and then write it corresponding to their middle year. So their middle year, it will be corresponding to 2018, that is 215. Now another easy way to get the positions right is whenever it is 5-yearly moving averages, you'll see that the first two and the last two trend values will be missing. So in the beginning itself, you can put blanks for the first two and the last 2 years. They will not have the trend values. Now similarly, leave out the first value 40 and then add 44, 41, 47, 43 and 55. You will get the total as 230. Then leave out the first two values and add the next 5 values. You will get 240. Then similarly, the next total is 255 and then you will get 270. Next, we need to find out the 5-yearly moving averages, which is also called as the trend values. So it means that 215 you have to divide by 5. So you will get 43. Next you will get 46. Then we get 48, 51 and 54. Now let us write the conclusion for this problem. So next, conclusion. So now observe whether the trend values are increasing or decreasing. So you observe that the trend values are increasing. So you can write the given time series indicates an upward trend. Subdivision B, fit a straight line trend equation reform y equal to a plus bx to the time series data given below. The years are given from 2014 to 2024 and the difference between the years is 2 and the corresponding values are given. The first step is to write given n is equal to 6, that is the number of years, and 6 is an even number. Then you write let y equal to a plus bx be the straight line equation. The two normal equations are the first one na plus b summation x is equal to summation y. Second, a summation x plus b summation x square is equal to summation xy. Now whenever n is even, the formula for x is deviation from the arithmetic mean of the two middle years divided by h by 2, which is equal to deviation from the two middle years are 2018 and 2020, that you should divide by 2, whole divided by 2 by 2. So h is the difference between the years, which is 2. Then 2 and 2 will get cancelled, you will get 1. So x is equal to deviation from 2019. So the first step is to mark years as x, value as y. Then you find out summation y, which is equal to 138. Next we'll form the columns x, x square and xy. So x now is deviation from 2019. So 2014 minus 2019 will be minus 5. 2016 minus 2019 will be minus 3. Then you'll get minus 1, 1, 3 and 5. So take each year and subtract it from 2019 and these are your x values. Our aim is always to make summation x equal to 0. Next find out x square. So minus 5 square is 25. Then you'll get 9, 1, 1, 9 and 25. So remember that whenever you square a negative number, it will become positive. So summation x square, we get it as 70. Next find out xy. So 12 into minus 5 is minus 60. 10 into minus 3 is minus 30. Then minus 20, 25, 90 and then you will get 205. Now as there are negative values, you be careful in the calculations. So you'll get summation xy is equal to 210. Now what we have to do is we have to substitute all the totals in the two normal equations and then find out what is a and b. So take the first normal equation NA. So it is 6a plus b into 0 is equal to 138, which implies 6a is equal to 138, or you will get a is equal to 138 divided by 6. So therefore a is equal to 23. Now take the second normal equations and we'll find out what is b. So it is a into 0 plus b into 70 is equal to 210, which implies 70b is equal to 210, or b is equal to 210 divided by 70. So you'll get b is equal to 3. Then you can write the last step. Therefore, the fitted straight line trend equation is yc equal to, now in place of a, you have to substitute 23 plus bx, so plus 3x. So the fitted straight line trend equation is yc equal to 23 plus 3x. Thank you all for watching Statistics Made Simple. Please do like, subscribe and share with as many students who are writing the second PUC statistics exam. I have solved 3 model papers this year, and I've also solved important questions on certain important chapters. Please do visit my channel Statistics Made Simple. It's going to be really helpful to most of you.